Dear valued connections, due to the numerous questions we have received from our BYST Energy Turkey technical team, we have prepared this video. We will try to answer your questions. As you know, BYST Energy designs energy systems and distributes them in Turkey for your service. We will address all questions related to battery energy systems in a single video. The questions will be directed by our electrical engineering partner Akın Sarıçam. By the way, since we prepared this video on behalf of our companies operating in Africa, Europe, and Germany, we will publish it in 3 languages. Thank you, Mr. Akın. The floor is yours.
Hello, I am Akın Sarıçam. I am an electrical engineer. I will try to answer your questions about sound and energy storage together with Mert Şen in a question and answer format. Hello, Mert. Hello, good evening, Mr. Mert. As the representative of ATESS, who is ATESS? What is its structure in Turkey, and how did the collaboration with you take shape? Can we start with that?
Of course. First, let me introduce myself briefly. I am Mert Şen, an electrical and electronics engineer, and I work as a chief technical officer at BYST Energy company. Regarding your question, ATESS is a company we began distributing for in the second quarter of 2025. We provide technical services all over Turkey located in 3 regions as ATESS and BYST. I will briefly introduce ATESS to you. Let me tell you about our establishment. ATESS is an energy company founded in 2014 by Taiwanese investors and a global company to manufacture hybrid and electric vehicle charging stations. It has over 600 megawatts of completed projects in Africa. It has more than 50 patents and its own products. I'd also like to briefly mention a site in Turkey. BYST became a distributor for ATESS in the second quarter of 2025. We provide authorized service and consulting services for ATESS in 3 regions of Turkey: Istanbul, Bursa, and Izmir. That is all I have to say for now.
Could you tell us about ATESS product range and what targets it is aimed at? Could you explain this?
Of course. To elaborate a little, our product range currently consists of hybrid inverters, and battery groups, as shown on the screen. These are our main components. In addition to these, ATESS has developed approximately 240 different accessories for projects. These can be used in systems, hybrid systems, or microgrid systems. Another feature of ATESS, which actually distinguishes it from other companies, is that it offers solutions to people in a modular way, which can be described as Lego-like. What I mean is this: our product range is as I have shared on the screen. To summarize, our main products are hybrid inverters. These range from home use to large factory use, which we refer to as 15, 20, 30, 40, and 50, and are transformerless products intended for use in homes. Our HPS series are industrial products with built-in transformers ranging from 30, 50, 100, 120 to 150. All of the ones I mentioned have transformers rated at 15 kilowatts, 20 kilowatts, 30 kilowatts, 40 kilowatts, and 50 kilowatts. Residential products, the most suitable ones. The others are HPS 30 kilowatts, HPS 50 kilowatts, HPS 100 kilowatts, and HPS 120 and 150 kilowatts with built-in transformers. These are products including transformer.
And what do you mean by with transformer and without transformer?
We mean the following. In products intended for residential use with a power range of 15 kilowatts to 50 kilowatts, there is no output transformer. After the electronic conversion is fully completed, the grid is connected normally. Therefore, the likelihood of damage from sudden power outages or fluctuating loads is normal. It is higher compared to an internal transformer. However, by internal transformer, we mean the following. For example, let's take HPS 100 kilowatts. We have a load that we want to power. We have a 90 kilowatt machine in the factory, and we have connected HPS 100 kilowatts. With the hybrid inverter, we can use our product both as an industrial UPS and for solar power. We can connect this product directly to the DC bus and use it for self-consumption. Additionally, by storing the DC power from the solar panels and batteries, we can utilize the stored energy during peak demand periods, thereby achieving higher efficiency and effectiveness. However, the main importance of the transformer here is that it protects both the device itself and the system, ensuring it remains active and linear.
Mert, I have a question. The last product you mentioned is the battery system with a transformer. Can we call these industrial systems? In other words, can we say they are designed for industrial loads, but they can also be used in more complex villas and such? Of course, especially in villas where there are heat exchanger and such.
Absolutely. All our products can be used in any area desired by the customer. There are no limitations whatsoever. I'll explain shortly. We have PCS 1200 and 1500 kilowatt products. Since their output voltage is not suitable for the standard voltage we use daily, the PCS 1200 has an output voltage of 550 watts, while the PCS 1500 has an output voltage of 950 volts. However, we can offer all our other products for use in homes, factories, or even on ships when necessary. However, as I mentioned, due to their output voltages of 1200 kilowatts and 1500 kilowatts, they are unfortunately not suitable for normal use. These products are designed with high output voltages to be easily adapted to preferred locations such as large gas fields or wind turbines. While we're on the topic of PCs, let's briefly touch on them as well. Our PCS product range also offers a wide variety of options. Our smallest PCS product starts at 100 kilowatts and goes up to 100, 250, 500, 630, and even 1 megawatt in a monoblock configuration, which we can provide to our customers. To briefly summarize our product range, we are a company that can produce hybrid and battery inverters ranging from 15 kilowatts to 1.5 megawatts. As you can see on the screen, I am currently sharing our hybrid inverters and battery inverters work seamlessly with all our products. Our product range and monitoring and control systems.
By using ATESS branded products, you can resolve various issues for investors or factories.
Let me share a quick example. The screen I am currently showing is actually a PCS screen. This is a simple diagram of a PCS. If we think of this as a factory, once we install this system in the factory, we can perform arbitrage alongside with our PCS. Blackout. We can supply our factory without interruption for 10 to 20 milliseconds during power outages. We can use it in a way that can reduce harmonics to 3% like an active harmonic filter. Of course, we do this only with the inverter. With the inverter, we have isolation on the output side of each of our dirty loads, which is outside the normal conventional systems. This isolation allows us to completely suppress the third, sixth, and ninth harmonics, as you can see in the diagram.
We suppress them in a way that has no effect on the factory. It acts like an active filter. How do we achieve this? We convert AC to DC and DC to AC. At this point, we can say that all harmonics are almost zero.
Mr. Mert, can you explain to us how much we can eliminate the problems in our factories and for our investors by using ATESS products?
As you can see on the screen I am sharing with you right now, we have our network section on the right side. Below it, we have a diesel generator and any load from the factory or residential. These three components, our grid, diesel generator load, and the bypass cabinet, which is our combining box, are connected to the bypass cabinet. Above the bypass capability, we have solar batteries, inverters, the grid, the diesel generator, and load inputs. After connecting all of these, we can operate using arbitrage if desired based on our judgment.
At certain times of the day, we can effectively bring our factory to an economical state by only charging and discharging from the grid. In addition, our PCBs can also be connected to MPPT solar charge controllers. What does this mean? Instead of just charging and discharging from the grid, we can store the power we get from the sun in our batteries and consume it when needed. Or if electrical conditions allow, which is not very possible in Turkey at the moment. But what I mean is that we can also generate income for our customers by selling the electricity we store from the sun back to the grid at certain times. Secondly, let's assume that our customer has an old inverter array installed on their roof. In other words, there is an old system in place. It is currently operational on the roof. You're welcome, Mr. Akun.
Mr. Mert, before we delve into this topic, could you provide a brief explanation of what arbitrage is and what self-consumption entails?
Certainly. The arbitrage system is essentially a profit-generating system where batteries are charged from the grid during specific time intervals and then either supply themselves or feed energy back into the grid during designated peak hours. To put it simply, the arbitrage system operates during times when energy is available, for example, during nighttime hours. It charges itself, fully fills the batteries using AC coupling logic, and then sells this energy back to the grid during peak usage hours, completing its cycle.
When it comes to self-consumption, it refers to using the energy we produce or our batteries or the entire energy we store directly within the factory or for any of our own loads. In essence, self-consumption is when we use energy entirely within our own premises without making any sales. Arbitrage is not currently permitted in Turkey. We are mentioning it here because we use it in Europe and Africa, especially drawing energy from the grid, storing it, and then selling it at a higher price when it is cheaper. EPDK does not currently permit this, but arbitrage is something that exists in the world. It will definitely happen in Turkey in the near future. However, we can consider the following scenario. During periods when our factory is not operating on Saturdays and Sundays, it can store energy and then use this stored energy when the grid is not available. It can use the energy it has stored from the sun. It can use this energy throughout the day without drawing any energy from the grid. Many factories do this because they don't work during weekends. They charge their batteries during periods when they're not working. This is great. We can think of this as arbitrage, but there's no selling to the grid for profit here. I wanted to tell our listeners this. Now, I have a term I use, I call it trash power plant. When I say this, everyone is very surprised.
What is trash power plant, friends?
There are facilities in our country where energy sales, Yekdem energy sales, have ended, and these will reach nearly 8,000 megawatts of power by 2027. Therefore, a solution is needed for these. Our suggestion is very clear. Let's use them all together. Let's use BS and generate revenue. What can we do about this? Could you please explain this issue, as we have done in Europe, of course?
Thank you. Mr. Yusuf, you provided a brief overview of your question. So what solutions can we offer for systems that have been in use for over 10 years and whose contracts have expired? As shown in the diagram I shared on the screen, the roof-mounted solar power system currently in operation can be connected to our old inverters using a bypass cabinet, which is one of our accessories. This provides us with the following benefits. I am referring to the older inverters that are still functioning without any technical intervention. Of course, we charge our batteries from the beach using the inverter. The electricity we store there can then be used as needed, either to power our load, feed into the grid, or stabilize the grid electricity, as was done during the electricity crisis in Spain with the Black Hawk system. This is entirely dependent on the customer's request and requirements. I hope I've answered your question.
Yes, of course. When I mentioned Turkey, you also mentioned Spain in relation to domestic consumption, but we can also use this in domestic consumption-based facilities in Turkey, or we can use it for land that is only intended for sale. I'm trying to simplify the terms a bit so that the audience can understand them better.
You use a lot of technical terms, and not everyone in the audience may be engineers. Some may not be familiar with this topic, but they are investors and have factories. You're explaining it in a way they can understand. Thank you very much.
Yes, Mert Bey, BYST and ATESS, can you list the main features that set you apart from your competitors?
This is actually a very important question. The biggest feature that sets us apart from other companies is actually our engineering infrastructure, which allows us to produce and manage solutions for projects. We are not a sales-oriented company. In other words, we are different from the norm. Instead of just selling, we are a company that focuses more on problem solving and niche projects, and that's the BYST part. When it comes to the part of ATESS, the biggest feature that sets us apart from other companies is our monoblock high-power product range solutions. We have a 500 kilowatt product in a single body. We have a 630 kilowatt product. We have a 1 megawatt product. We also have a 1.2 megawatt product.
We have a 1.5 megawatt product. In addition, we can actively use 5 megawatts inside a container anywhere in the world. We are one of the top 5 companies in the world capable of manufacturing a 4.5 megawatt using 20B containers. In fact, our other major advantage is that the components used in our equipment are carefully selected for their quality, and the products themselves are of the highest quality. Another key factor that distinguishes us from other companies is the flexibility of our systems and designs. What does this flexibility entail? We can parallel up to 8 of our high power devices. This means we can parallel 8 1.5 megawatt devices to create a 12 megawatt monoblock bodied power station. How does this benefit us?
Let's say you are in Bandırma and you have a company with very large megawatts wind power plants. You take our station and place 10 of the 5 megawatt containers I mentioned earlier in parallel next to it. This does the following. Our 1.5 megawatt containers are directly optimized for wind turbines. This is because our AC voltage is 690 volts, as mentioned earlier.
Most wind turbines also operate at 690 volts, so they can be seamlessly connected to each other via direct coupling, enabling us to provide energy solutions, arbitrage, and grid stabilization without any issues. Of course, I would like to reiterate that arbitrage is not possible under current Turkish law. In Turkey, storage can be used for personal consumption when necessary, but not for sale. In short, that is the difference between us and other companies.
What are the main areas of focus during the post-sales installation phase, remote monitoring, maintenance, and software updates?
After sales and other technical services, we are actually a very strong company in after-sales marketing. How are we a strong company? We have our own after-sales support teams in 7 locations around the world, in addition to our distributors. One of them is in Turkey. There are also teams in Northern Europe, Germany, the Netherlands, and France. There are teams in 2 countries in Africa. In China, we have both production facilities and technical services. In Taiwan, we offer similar post-sales technical services. Additionally, as the Turkish distributor, we provide post-sales installation, technical support, software, and spare parts across all of Turkey from our 3 cities, Istanbul, Bursa, and Izmir. We provide services to all fire and brand-independent storage facilities in terms of both installation and annual maintenance contracts and sustainability.
You mentioned wind power plants earlier. Now let's talk about the total power of the inverter and battery being the same. There is a 33.6 megawatt wind power plant. You will provide me with 33.6 megawatt inverters and a 33.6 megawatt battery bank. Available power capacity. I will specify this in parentheses. For example, you are providing a 33.6 megawatt battery bank. I'm saying net 33.6. How long will it take you to deliver this? If it's a turnkey project?
Then let me tell you about our short processes. We carry out our projects as follows. First, we contact our customer and learn their requirements. Based on these requirements, we start the project process. The initial stages of the project are drawn up. Once we reach an agreement with the customer, we obtain approval for the quote. Following that, our production processes begin. If we use the previous project as an example, for a 33 megawatt facility, our production process takes approximately 14 to 16 weeks, and after that, following an 8 to 10 week transfer process, we can deliver the products to our site. After receiving the products, they arrive at approximately 80-85% complete. We then perform easy on-site installations and connect the ESC cables, completing a 33 megawatt project in approximately 3.5 to 4 months. Of course, the production line's workload can significantly affect these timelines, because the lack of raw materials means that we have to rely on other companies with large stocks of batteries, and the lifespan of the batteries is very important. Once an order is received, we begin large-scale production. However, we already communicate with our customers in advance to inform them of this and work to resolve any issues smoothly.
Mert Bey, could you briefly provide some information about other product ranges? Can you continue with that?
Certainly, I will discuss small and medium-scale energy projects with you. The hybrid series HPS and ATESS you see on the screen are typically used together to provide optimized power to our customers. Our hybrid series inverters are grouped into 30, 50, 100, 120, and 150 models. Similarly, our American-type products are also available in the same standards. When I say EPS series with the same design, I mean that they are not separate, as I mentioned earlier. The MPPT output bits and transformer are all integrated into a single monoblock. Additionally, as mentioned earlier regarding cabinet and grid transfers, we can easily achieve levels below 10 to 20 milliseconds. Remote control, startup, and dry contact signals are also available as standard features for diesel generators. We can parallel up to 8 EPS products. Like other products offered by ATESS, the operating modes here are also highly flexible and programmable. Another important feature is HPS. Our HPS inverters can be used with industrial UPS logic. The main reason we use HPS with UPS logic is that when comparing UPS systems, the power supply time in UPS systems is 10-15 minutes, whereas in our GPS series hybrid industrial inverters, the power supply time is 2 hours to 2 hours and 15 minutes. In terms of minimum storage options, this provides us with both longer storage times and seamless operation due to high capacity during sudden power transfers in the electrical system. Let me briefly explain these programmable operating modes. These operating modes are for self-consumption, meaning they do fully meet our own needs. Similarly, as I mentioned, there is the grid charging and discharging sales mode, peak shaving mode, and the microgrid island operating mode. I would like to explain this microgrid mode in more detail. Microgrid is important in the following way. Normally, this can be done on most devices. It is an operating mode, but it has a nice feature. Since it has an internal isolation transformer, when we run it here, the harmonics at the bottom are completely zero.
Another feature is that our EPS series can be used as industrial UPS systems. What does industrial UPS mean? Unlike the UPS devices we normally know, which are connected in series to the system, we connect this device directly to the solar array, load our battery group and hybrid inverter onto it, and then connect it to the grid.
And when the power goes out, we offer a switching time of less than 10 milliseconds with zero harmonics and a backup runtime that is nearly 6 to 7 times longer than a standard UPS. What does this mean? 6 to 7 times longer than the standard. While a standard UPS provides backup power for 15 to 20 minutes, our inverter and battery system operates at minimum capacity. We can provide power supply durations of approximately 2 hours and 10 minutes at the input capacity.
In other words, while the market conditions typically offer 6 to 10 minutes or 10 to 20 minutes, our goal is to establish an energy storage system starting from 2.5 hours in this series. Additionally, we can connect a generator to our system. Is that correct?
Of course, a generator can be connected.
We can connect other secondary power sources and provide clean energy with zero harmonic levels to our factory, home, or villa. In other words, it is not affected in any way by voltage fluctuations or low voltage.
Yes, as I mentioned earlier, we got hybrid inverter. Let me also briefly mention our transfer cabinet. It is compatible with the HPS hybrid inverter I showed you earlier. It can communicate and control directly and seamlessly. Its built-in transfer feature enables seamless switching between the grid and the generator, and it has the ability to send remote commands when the grid power is cut off. Here you can see another typical diagram. In our diagram, you can see our network and the diesel generator. We have the transfer cabinet I mentioned earlier, our hybrid inverter, our DC cabinets, and the cabinets to which our smart devices are connected. We have solar modules, solar panels, and our combined system to which the solar panels are connected. So as you can see above, we have DC collectors. Our monitoring systems have their own monitoring server for our internet router and our computers and phones. The main difference between all of these and the battery inverters is that we connect our loads directly to the shared AC. But the industrial logic I mentioned earlier comes into play here. With our HPS hybrid models, we pass the clean energy through the inverter, ensuring a clean energy supply. as I mentioned earlier, this hybrid inverter allows us to adapt the existing system on the customer's roof or next to their factory. When adapting this, we don't use the bypass capability, but instead install a distributor and collector cabinet at the output of the hybrid inverter. This is called MDB combiner unit. Inside this cabinet, we connect both the loads and the existing inverters that were previously installed, similar to our bypass capability. The most misunderstood part here is the following. After establishing this connection, we ensure that after the ATESS communication is fully set up, if the existing inverter is set up for sales, the sales are being handled through a third-party energy control software, which is also part of our distribution. Do you have any questions?
Yes, this is very important because it is a feature that sets us apart from our competitors. We can integrate different inverters and systems, and we handle the software through the company we obtained the distribution. Please tell me, would you recommend these products, inverters and storage systems also for military facilities, as we did already in Africa?
Of course, both our HPS and PCS series and other products undergo nearly all types of testing for operation under harsh conditions. I'm referring to tests such as temperature and iron current loads, which are actually considered industrial product standards for our products. Actually, our products are very good in terms of quality and more than meet the requirements. But our industrial products really offer many times more than what is required, both because they are self-contained and because of the quality of the components used. There may be an advantage for military use. There are devices that must never shut down in the military. There are tools that must always be critically powered. These could be transmitters, radios, antenna stations, or satellite receivers. We could provide numerous examples. By using our HPS products with a shared battery pool, rather than individual inverters as found in other brands, we can power varying loads with different power requirements in different locations and provide tailored solutions.
This is a very important point because this is not possible with many other brands. What I mean is this: we have one battery unit. It is a container that we can install anywhere. Using the energy from this container, we can power a 150 kilowatt device in one location, a 50 kilowatt device in another location, and various devices ranging from 30 kilowatts, all without them being connected in parallel, ensuring seamless operation. The key point here is that even if one device malfunctions, the others continue to operate as if nothing had happened and do not experience any issues with their own critical functions. In other words, by using a central storage unit instead of a central inverter, we have resolved this issue. Very good. The thing we're focusing on here is critical. Mr. Akan, please.
In buildings, in factories, in our military facilities, approximately between the grid and the generator. When the grid goes out, the generator kicks in within 10 to 15 seconds or even 20 seconds. How long does it take for our system to kick in when connected to the ATESS?
You can also see this in our catalogs. The loading times are usually listed as 10 and 20 milliseconds. However, the critical loads they received in the test documents are also accurate. The switching time in the power supply is 8.6 milliseconds, as recorded in the test documents. In other words, in the blink of an eye, these hybrid products switch over without any interruption, ensuring that the end user experiences no downtime. This is the essence of an uninterruptible power supply, UPS.
Yes, that's exactly what I was going to say. Uninterruptible power supplies, UPS, are present in all our military facilities. They are in servers, but more importantly, they are in radar systems. I call these silent generators. Actually, I call the systems powered by our FPS series silent. We can also increase the capacity as much as we want. Since they don't have the same features or responses as UPS units, they have a very long lifespan, and since we connect them in series to the system, we never experience any power outages. This is very important.
As far as we know, it's an active, harmonic filtered, silent, uninterruptible power system. Is that correct?
We can say it is correct. Speaking of industrial power systems, I'd like to go back a bit. In short, for higher power levels, we can actually create another system. We call this a DC coupling uninterruptible power system, and we build it using a battery inverter. The load we feed here is completely harmonic zero. The reason for this is as follows. Thanks to DC coupling, we convert all the incoming electricity and charge our batteries through a common bus bar. In addition, we feed our PCS. At the PCS exit, even we feed all the load through DC. Our system passes the electricity through an isolation transformer, again protecting our factory from peak loads. In this system we use, harmonics and dirty voltages are completely eliminated, and we are able to power the desired loads with 100% clean and reliable electricity. The same applies to the grid generator system. If you have an existing solar plant unit, we can make it work again with this system. It can still be used as before. This is my favorite feature. Another feature is that it is available for sale. Let's say our transformer power is insufficient and there were no call letters. A call letter was issued. It was upgraded 20 months later, but a new machine was purchased. There are changes at different times. Here, by setting up our method, for example, there is a 630 kilowatt transformer. By connecting a 600 kilowatt regulator unit to this location and synchronizing the battery inverter groups with the system at 3 times the capacity of the battery inverter, we can increase the output power of the 600 kilowatt transformer to 1 megawatt at 400 volts. Here, our customer doesn't lose any time. Now they are completely supplied with harmonics-free clean energy.
Wait a minute, Mert, is this legal? Yes. I can say it is 100% legal. I can't rise the transformator from 600 to 1000 because it's impossible for the distribution network company there or the facility in Europe to supply that power. Then we'll call you Mr. Mert. You come and set up a system for us so that my current 600 kilovolt ampere actually behave like 1000 kilovolt ampere and I'm freed from that waiting time. This is very important.
Not only are you freed from the waiting time, but you're also unaffected by power outages. If your roof is suitable, you can also connect solar panels to it. But of course, this is not yet fully implemented in Turkey. Everyone knows we're waiting for this law to come into effect. But speaking of Europe, in Europe, you can connect panels to the roof, install batteries, and together achieve 400 kilowatts of power. With a 4 kilowatt regulator group, they can increase a 1 megawatt transformer to 1 megawatt. There is no clean and reliable method to ensure that nothing is affected by power outages and that the system, factory, and farm continue to operate.
I am in Africa. The nearest grid connection is 500 kilometers away. I have an energy requirement of 8 megawatts. How do you set this up?
Actually, how do we set this up? If I show you on the screen, you can ignore the area I'm drawing with my pen. When we ignore this, we have done the following. We have obtained an AC voltage with our batteries. The battery inverter and this system, along with the solar panels we calculated, are needed next to the container. Here, with a PC unit called a microgrid, you can send electricity to any location you want, such as an airport or the oil well project we are currently developing in Africa. We can increase this power from 100 kilowatts power to 1 megawatts in a monoblock configuration by connecting units in parallel, scalable up to 8 megawatts. This is entirely dependent on the customer's requirements, the issues to be resolved, and the scale of the project. We can make DC coupling here. We can also provide power from a single common pool using AC coupling to different areas in parallel. As we mentioned, this is entirely based on the request form we receive after communicating with our customers. It depends on the information we gather from them regarding our design. However, even if the desired location is at an altitude of 2,000 meters and in areas without electricity, with ATESS we can design and implement high-power ESS containers to provide a solution.
How do you ensure fire safety, which is a very important issue?
How do we ensure fire safety? Let me talk about the containers that will be used. All our containers are equipped with fire detection sensors, CCTV cameras, and fire extinguishers, ensuring all necessary safety measures are in place. At the same time, our containers also have ventilation covers and explosion covers. Some of our containers can display different power levels, provided that they are on top. We can also provide exhaust fans at the entrance and exit. Of course, this depends on the power. However, we guarantee that all the containers we produce are as capable and reliable as possible in terms of fire and human safety.
Mr. Mert, you keep mentioning the battery system. Could
you provide us with some information about the battery systems? What is the difference between gel batteries and other batteries? As far as we know, the lifespan of these products is estimated to be approximately 2 or 3 years. They reach the end of their lifespan after 2 or 3 years.
Could you provide us with more information on this? Additionally, you mentioned the cycle. What does this cycle refer to? 6,000 cycles, 5,000 cycles, 4,000 cycles. Could you provide us with more information on these?
Of course, let's proceed by sharing the screen to create a visual representation. The product you see on the screen right now is entirely ATESS' own design and has its own R&D and patent. Similarly, the remote monitoring and management system is also inside our battery cabinets. The long life of 6,000 cycles mentioned there is the cycle we mentioned earlier. A cycle actually represents one movement of the battery. So that means that when we use a battery for charging or discharging, it will last for 6,000 cycles. We can use it, we are able to use it, we are capable of using it. It means it can be used, it can be charged 3,000 times and discharged 3,000 times. Lithium iron phosphate cells can be used. The biggest difference between lithium iron phosphate cells is their long life and structural difference compared to normal gel batteries or AGM batteries. We can achieve the desired voltages using series connected cells. Lithium is present in both batteries and iron phosphate. However, this is per cell. As I mentioned earlier, with battery management systems, we can individually control each cell and charge them at the same rate, resulting in significant efficiency gains, both in terms of lifespan and output power. Compared to standard gel and AGM batteries, lithium iron phosphate batteries offer more power and performance. Let me briefly introduce our products. The products you see here are 51.2 volt, 14.33 kilowatt hour units. These have highly flexible modular structures within these cabinets, which are entirely self-contained. The product you see here consists of 11 units of 51 volts and 14.33 kilowatt hours. As for the side, the same product is also available in 8, 9, 10 cell and 11 cell configurations. The 8 cell product listed on the far right is our shelf type product used exclusively for containers. Our cabinets are rated for a maximum of 51.2 volts. At 14.33 kilowatt hours, we can provide our customers with a total battery capacity of 157.6 kilowatt hours. Similarly, another product class we offer is container-type products that are identical to the cells we just mentioned. These range from 172 kilowatt hours up to 215 kilowatt hours. They are identical to the cells we just mentioned. The only difference is that they are designed specifically for containers and volts. That's all I have to say about the workshop. As for our residential batteries, they are not much different from the others. The only difference is that they are residential type batteries available in 5 kilowatt and 7 kilowatt hour capacities. The cells used are exactly the same. The same remote balancing system is separate, and we also have two optional options for our home use batteries, i.e. small capacity batteries, 0.5 C rate and 1 C rate. When I say 0.5 C and 1 C, you can see the value written below. The value here refers to the inverter output power being half of the battery power when we say 0.5. When the inverter power and battery power are equal, it means we can transfer the same capacity of power to the output. Normally, there are only a limited number of companies in the world that have output power, but ATESS has achieved this as a pioneer and is able to supply power smoothly. If you have no further questions about the battery, we can continue.
Could you explain the BMS system a little more? In other words, what does BM mean in a short?
The BMS system means the following. It is the name of the device that controls each cell in the batteries individually in terms of temperature, voltage, and amperage, and manages them during charging and discharging. The English term is battery management system. It is a battery control unit. The advantage of this is that other products and other batteries do not have this system, so cell deaths and voltage differences between cells can occur in the system. But in scenarios where this is possible, the system can protect itself by cutting off the output or stopping the high heat input during charging to protect itself under the name of protecting these systems under varying temperature and current conditions. Essentially, the primary purpose of this system is to provide an electronic unit that enables the battery to be charged under normal desired conditions and discharged under desired conditions.
This means that in the event of even the slightest issue with a cell, the system immediately takes control and disables the set. This ensures zero risk of explosions or fires.
Absolutely. I forgot to mention that earlier. You are absolutely right. In the event of a fire, the thermostats on the system detect the heat or temperature and, if critical levels are reached, shut off the power supply to ensure that the system is safely shut down and protected.
So, in addition to the cost, the BMS system must be of such high quality that it is sustainable and long-lasting.
Absolutely. I would like to add something very briefly. It's just something that came up today. Another issue is transformer fires during sudden surges in the summer. Storage also plays a very critical role in transformer explosions. How critical is it? Summer is here. As you know, it gets very hot in Turkey. People overload the transformers due to the air conditioners. The power of the transformers is exceeded. That is lack of control, is what we can call it. What scenario could have been followed if there had been storage? If there had been storage, even if we loaded the transformers, the load on the transformer would have been reduced by the power and capacity of the storage, perhaps by 50%. And it would have continued its daily operation. However, currently in our country, transformers are being overloaded due to the lack of storage or its non-residential nature. Air conditioners are now widely used in our country, especially during the summer months. Additionally, with the increasing number of electric vehicles and their charging stations, we are also facing transformer-related issues. This is my humble opinion. With the increase in storage and domestic numbers, there will be a decrease in this area among large consumers as well, and we will prevent malfunctions at the state level. Another area of use for storage is when we take Spain as example. When production facilities are connected to the medium voltage side, we can actually stabilize the grid. In terms of frequency, voltage differences, and voltage balancing, it provides significant benefits and opportunities for the grid. If we look at an interconnected system where storage is connected, the advantages are numerous and the disadvantages are minimal. When I think about the disadvantages of storage, nothing comes to mind. In fact, we discussed this just the other day. When we look at it, the only drawbacks are the space it occupies and the investment cost. However, I hope that these will be implemented in the future to avoid creating a global problem for the country. Thank you very much. It was a great presentation. I look forward to your next one. Take care. Thank you very much. It was a nice session.
Looking forward to the next one. Take care.
See you soon. See you soon.
Sales are on track. Production is strong, but is the future really secure? The lights may be on today, but is there a guarantee they will stay on tomorrow? your power going even if the power goes out. Keep your business running even if the energy supply is interrupted. Work continues even if the lights go out. Look to the future with confidence with battery energy storage systems. BYST, building your sustainable tomorrow.